Hi students, good morning to all. Today we are discussing facade design pattern continuation. Okay, that is implementation section, noun uses, and what are the related patterns of facade design pattern. In previous video we discussed facade design pattern. Now the continuation of facade design a pattern. Okay, coming to the implementation section. Consider here the following issues when we are implementing a facade design a pattern. Okay, first one is nothing but reducing client subsystem coupling. What this meaning in the sense, reducing client subsystem coupling in the sense, the coupling between clients and the subsystem, it can be reduced. So here by making the facade design pattern, it is an abstract class with concrete subclasses. Okay, we are implementing for all these methods for different implementations of a subsystem. So then the clients can communicate with the subsystem through the interface of the abstract facade class. So this abstract coupling keeps clients from knowing which implementation of a subsystem it should be used. Okay, which implementation of a subsystem is to be used. So an alternative to subclassing is to configure a facade object with different subsystem objects. So we need to customize the facade design pattern and simply replace one or more of its subsystem objects. Okay, this is the concept of reducing client subsystem coupling. And coming to the second key point, that is nothing but public versus private subsystem classes. Here listen carefully. A subsystem is analogous to a class in the both having interfaces and both encapsulating something, in the sense both data methods classes we need to combining like one unit. Here a class should be encapsulate state and operations, and while a subsystem encapsulates classes. So just as it's useful to think of the public and private interfaces of a class, and we can think of the public and private interfaces of a subsystem. So here the public interface to a subsystem, what it consists of, it consists of classes that all clients can access. The private interface is just for a subsystem extenders. Okay, listen carefully. So the facade class is part of the public interface. Of course we can say it's not the only part. So here the other subsystem classes are very usually public. For example, the classes parser, the subclass has parser and scanner in the compiler subsystem. It is a part of the public interface. In the sense we are making subsystem classes privately, so it would be useful. But a few objects oriented languages it support or not, both C++ and Smalltalk, it's traditionally have had a global namespace for classes. So recently we can study in C++ standardization. We are adding some namespaces to the language which will let you expose just the public subsystem classes. Okay, this is nothing but the implementation section of a facade design pattern. And coming to the noun uses, noun uses in the sense examples of the facade design pattern we are using at real world systems. Okay, in the sense here coming to the ET++, it's one of the application framework here. It's an application, it can have built-in browsing tools. We are browsing tools for inspecting its subsystem objects at runtime, especially at runtime. Okay, and we are browsing the tools where the tools are implemented to a separate subsystems, in the sense decouple the subsystems that will include a facade class and called, we can say, programming environment. Facade class called programming environment. Here the facade, what the facade design pattern defines operations such as what operations here, inspect object and inspect class for we are accessing the browsers. Here look at this facade design pattern, what it defines here, operations such as inspect object object and inspect class for we are accessing the browsers. Okay, here we are taking some choices, operating system choices. Here one more we are using the compiler example in the compiler example also. Here now we want to studying operating system choices. In the sense the choices is also uses facade design pattern. Whatever we need to compose objects, many frameworks into one in the sense into single. Okay, we are using a facade, we need to compose objects, many frameworks into one. So here the key abstractions in choices, these are all processes and storage, and we are addressing some spaces. For each of these abstractions there is a corresponding subsystem, and we need to implementing as a framework, so that we need to support the porting choices to a variety of different hardware platforms. So these are all, so these of two subsystems have a representative that is nothing but facade, that is nothing but facade. These representations or file system interfaces, that is nothing but storage. And we can say one more, domain in the sense address spaces. Okay, this is the diagrammatic representation. For example, I have to be explained here, listen carefully. The virtual memory framework it has a domain, and it's a facade design pattern. So a domain represents, what here represents an address space, what here represents an address space. What it provides, a mapping between virtual addresses and offsets into memory objects. Okay, and files or backing store. Okay, so the main operation on a domain, what it support, adding a memory object at a particular address, and we need to removing a memory object, and we are handling a page fault. So we are preceding the diagram how it shows the virtual memory subsystems. Here the virtual memory framework, what this subsystem, it uses the following components. Internally it will use some following components. Those components are here. Memory object represents a data store. We need to store the data at memory object. And the second key point, memory object cache, what it caches, the data of memory objects in physical memory, and coming to the at that point, and coming to the next point, memory object cache is actually a strategy that localizes the caching policy. Okay, that localizes the caching policy. And coming to the last key point, we need to addressing the translation. Address translation encapsulates the address translation hardware. Okay, we need to address the translation, we need to encapsulate the address translation hardware. Okay, here what the main concept here, the fault here, the fault operation is whenever a page fault interrupt in the sense stop occur. So here the domain finds the memory object at the address, causing the fault, and delegates the repair fault operation. So we need to say the cache associated with that memory object. So the domain can be customized by changing their components. And coming to the related patterns, the first one is abstract factory is one of the related design pattern. It can be used with the facade design pattern. We need to support an interface for creating a subsystem objects, in a subsystem independent way. So abstract factory can also be used as an alternative to facade design pattern. Whatever you need to hide the platform specific classes, Coming to the mediator section, it is a mediator also, it is very similar to facade design pattern in that it abstracts the functionality of existing classes. In the sense, however, the mediator purpose is to abstract arbitrary communication between is to abstract arbitrary communication between objects, and we are oftenly centralizing the functionalities that doesn't belong in any one of them. So a mediator colleagues are aware of, and we need to communicate with the mediator of communicating with each other directly. So here facade abstracts the interface to subsystems. We need to make them, it is very easier to use. It doesn't define the new functionality, and it is supposed to use subsystem classes, it don't know about it. So finally, we are usually only one facade design pattern object is required. So thus facade objects are oftenly used at singleton design pattern. Okay, this is the concept of here we are using the related design patterns: abstract factory, mediator design pattern, singleton design pattern. Okay, here abstract factory design pattern, it can be used with the facade to provide an interface for creating subsystem objects in a subsystem independently. Coming to the mediator section, the mediator it is very similar to facade, it abstracts the functionality of existing classes. And coming to the singleton, facade object is required. The facade objects are oftenly used singleton design pattern. Okay, up to now, thank you ma. If you have any doubts regarding the facade design pattern, can you please ask me? Thank you.